Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we begin to look at rates of change. So what we're looking at is how quickly one variable changes with respect to another variable. So in this graph here, I'm using y to be distance in meters and x to be the time in seconds. So I was thinking I'd use the example of someone running a 40-meter race. So you can see that the person has run 40 meters in 8 seconds. So their average speed is just 40 over 8, which is 5 meters per second. So that's their average speed, but we know if someone was running a race, they wouldn't go the same speed all the time. They'd start off a bit slower and they'd pick up speed as they go. And obviously if they kept running, eventually that speed would slow down because they'd get tired. So the average speed here is 5 meters per second, but the thing is this runner is traveling at a different speed after different times. So we're going to look at the speed at different times. Now, speed is a rate of change. Speed is distance over time. So we can write it like this. It's the change in distance. That little triangle means change. Change in distance over the change in time. So let's look at the speed for different points on this line curve looking thing. So the person started here, had gone 0 meters in 0 seconds, obviously, and they'd only gone up to 5 meters after 2 seconds. So their speed for the first 2 seconds is just 5 over 2 or 2.5 meters per second. And that's a rate of change. We're saying in the first 2 seconds, the distance changed 5 meters. Change in distance 5 meters, change in time was 2 seconds. 5 over 2, 2.5 meters per second. So then in the next 2 seconds, they've gone from 5 meters up to 15 meters. So the next 2 seconds, their speed, which is a rate of change, they've changed their distance by 10 meters in 2 seconds, so the speed would be 5 meters per second. So between 4 and 6 seconds, they've again gone another 10 meters in 2 seconds, so that would also be 5 meters per second. And of course, for the last 2 seconds, the person was running faster. So between 6 seconds and 8 seconds, they have gone from 25 meters to 40 meters in 2 seconds, so it's 7.5 meters per second. So we're going to use this idea of rates of change in calculus. The idea is we're going to get a curve that looks like this, but the rate of change of the curve is different at different points along the curve. So it doesn't matter what we call the variables here, y and x, whether they represent distance and time, they could represent, money and time, something like that. Whatever they represent, we're going to look at functions like this that don't have a constant rate of change. And this is an example it didn't have a constant rate of change because the speed of this person was different at different points along the curve. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.